Next item is the nutrient pollution influence on red tide in Southwest Florida. The purpose of this presentation will share findings from a joint research effort and recent publication looking at intensification factors of harmful blooms. The project examined relationships between land-based nitrogen loads and red tide events in Southwest Florida. It's connected to the CCMP in a way as it relates to Water Quality Improvement Action 5.1, support harmful algal bloom, HAB research and monitoring, and measures to reduce their environmental, social, and economic impacts to the identification and reduction of anthropogenic influences.
Thank you. Good morning. My name is Suau. I actually served on the technical advisory committee for the NEP, but also been practicing as a hydrologist in Southwest Florida for about 40 years. And I wanted to present some findings from a paper that recently got published. The work was done maybe a couple years ago, brought with the NEPs and Jennifer and David Tomasco kind of joined together to help get it published. Miles Medina has also done a lot of work on red tide and statistical analysis thereof, participated and contributed quite a bit. And Lenny Landau, who kind of started this whole thing, he's a retired engineer up at the time we lived on Longboat Key, and he'd been looking at red tide and trying to correlate how it starts and ends using a lot of different factors. And one was rainfall. And I said, well, you know, it's runoff and the loads that go into the bay of nitrogen that would probably be a better correlation. So I worked with Lenny on that, and that's what I wanted to present. So real quick, red tide, I think we all know it starts out on the Gulf of Mexico. It's probably always there, just in low concentrations, but under the right conditions, low current temperature, and other factors, it can move to the shoreline where it can, where the severity can increase, grows, and moves around. Aerial show or I guess satellite images show that this event 22 starting down near the Charlotte Harbor, Caloosahatchee, and eventually moving up to Sarasota Bay. So it's very complex. And other imagery from the European Space Agency, shows the impacts along the shoreline. And I think we've reached the conclusion that there is a relationship between what happens on the landscape in terms of changes and alterations and nutrient increases and what happens in our waterways, including red tide. So the premise is, again, that humans don't cause red tide, but if it makes it to the shoreline, then there's opportunity for anthropogenic nutrients as well as negative nutrients to increase the red tide. And these studies, like I said, there's been other studies that have been recently done by Medina and Dave Tomasco showing statistically there's a relationship, particularly in the Caloosahatchee River area. So for this study, like I said, it was kind of in partnership with Sarasota Bay and Charlotte Harbor Estuary Program. So we looked at all of the red tide data points in that geographical region. And then on the land side, we looked at all the gauged watersheds. Watersheds where typically the USGS has been measuring flows continually, sometimes going back almost 100 years. And at those same locations, you see those areas are highlighted in pink, the gauge areas. There's also nutrient concentrations being measured monthly by either the water management districts or FDP, sometimes local county government. So we're able to match up both the concentration and the volume, because the tons of nitrogen that are being released is the product of the two. How much water, how concentrated is it with nutrients? We looked at 5 watersheds, including the Mayaca River, where it's gauged, Peace River, Horse Creek, Joshua Creek, and the Caloosahatchee. The unique thing about the Caloosahatchee, of course, is that it also, there's discharges being introduced to it at the upstream end by Lake Okeechobee releases. So that river is also taking on the area in green, or a percentage of that area that goes into Lake Okeechobee and then is released to the west coast. So that's kind of a unique situation. And you can see that Kissimmee River, the Lake Okeechobee watershed is probably not as big as the other watersheds combined. And on the Caloosahatchee, that I mentioned, it does accept, the gauges that was looked at was the gauge S79, which includes both the Caloosahatchee, or a portion of it, at that location, and the discharges from Lake Okeechobee. The period that we looked at was between 2007 and 2022, because the red tide data really became more robust during that period. Typically trying to get it almost all the time, not just when there's a red tide bloom. So we had really quite a bit of data. You go further than that, and the data for red tide is just not as robust. And we looked at two thresholds to define red tide. One was when the maximum daily sale count was above 100, or 100,000 sales per liter for 30 days or more. We looked at a second threshold that was above 100 sales per liter for 30 days or more. And this is the data plotted at log scale on the y-axis. So when you do that, these events tend to really pop out. One of the things we notice is when it gets up to 10,000 cell counts, it's going to 100,000 pretty quickly. So there was only one event where it got up over 100,000, or we got up over 10,000 30 days, but it didn't last 30 days over 100,000. Other than that, the events were pretty much concurrent, and there were 12 of them, 11 to 12, depending on the threshold during the study year. And from doing that, we could determine the number of days that the red tide event lasted. Anywhere from 30 days to well over a year in some cases. The only other thing that we noticed was that typically, if red tide is not being measured, it's not being measured on the weekend. So during the week, it's pretty typical that there's measurements being taken, but on the weekends, which would constitute 29% of the days, we saw about 23. So there is some readings on the weekend, but that's typically the time where there may not be readings for red tide. Okay, so this is really the summary of the analysis of the load. This is not a model. These are actually based on the measurements. The upper graph are what we call the hydraulic load. That is the total amount of water every month that's being discharged into ultimately, I guess, the Gulf of Mexico from these 5 watersheds. The red represents the Caloosahatchee contribution. The blue at the bottom represents the lower part of the graph represents Peace River. And there's other colors of the other contributors. You can see the main contributor is the Caloosahatchee typically. Peace is not insignificant. The lower graph then is the pounds of nitrogen every month that's being discharged. And again, they're color coded by where it's coming from every month. And it almost matches the hydraulic load, the volume load. They're pretty proportional to it. So the volume is a pretty good indicator of nitrogen load. So just real quick, the relationship, like I said, we looked at both the hydraulic load and the nitrogen load as a explanatory variable. But what we are interested in is comparing or trying to find a correlation between how much nitrogen is released and how long the red tide event lasts. That's really the only thing that we could get from the red tide data was inspiration. And specifically what was looked at was a load of nitrogen, how much nitrogen went in to the Gulf, the bays, 30 days before and 30 days after the red tide event started. So think of that as a reservoir of food for red tide. There's other nitrogen that will come into play once the red tide event starts, but that's kind of the initial fuel, if you will, that we tried to see if there was a relationship between that and the duration of red tide. This is the results for the nitrogen loads and the two different thresholds. So the graphs on the left represent all of the watersheds correlated. The total nitrogen load from all 5 watersheds versus the duration of red tide. That had an R squared, I think was about 0.5, 0.37, 0.5. And then we looked at just the Caloosahatchee by itself. And the relationship became much tighter, indicating that may be the driver to what's really happening. Because when we looked at the other 4 watersheds without the Caloosahatchee, the relationship pretty much fell apart. So the R squared for just the Caloosahatchee was up around 75% correlation. And we saw almost the exact same thing when we looked at hydraulic overlying. Again, that's a surrogate for nitrogen loads based upon the data. But it had basically the same, we saw almost the exact same results in terms of the correlation, particularly with the Caloosahatchee River and its nitrogen load. So in conclusion,
Because you have to let it
It's the-
do its thing.
It's the teams glitching, sorry.
I used
No, it's the teams. Maybe there's a weak Wi-Fi signal.
Oh,
I can
wow.
reshare if it doesn't stop.
Okay, if it won't stop, we'll have to reshare. Okay,
so
sorry.
so what I want to say
Oh, if you want to go back one, I think. Now just click it real light. There you go.
in conclusion, again, if red tide events are initiated offshore than the water mass, and the water mass is transported to the southwest coast of Florida, then these negative loads can affect their duration. The overall pattern appears to be driven by the Caloosahatchee. There may be some additional, I know Niles is doing some additional statistical work on Peace River in particular to see if there's some things there. That is consistent with some of his earlier findings. When we did this analysis, we were not even aware that Miles was doing the work and found out about it. And that's how we got hold of it. So it's kind of coincidental that we were doing this independently at the time. And again, the hydraulic load had almost the same ability to explain what was happening. So really in conclusion, this indicates there's a relationship between how much nitrogen is put out, particularly from the Caloosahatchee, right before and right after the red tide event starts, and how long that red tide boom is going to last. That's it. Nothing more, nothing less. It doesn't predict how severe it's going to be, where it's going to go. There's a lot of other complicated factors that are maybe more complicated than that. But this also doesn't in any way say that other projects to reduce nitrogen or nutrients aren't valuable to do those kind of investments, because we've got all other kinds of issues with the macroalgae we heard about, the fish kills, seagrass coverage. So all projects are important, but this indicates that the Caloosahatchee in particular has a real strong relationship with how long our red tides last. And what it would allow is for projects to be evaluated in terms of how many pounds of nitrogen would it be reduced, therefore how much shorter might the red tide events be. This is a table that pretty much shows for the Caloosahatchee Basin what the different contributions are, or the sources, if you will. And one thing, of course, is top solids, that the Lake Okeechobee is about 61% of the load. So that is a huge source if you want to look at reducing the different sources. As, as someone who's lived and worked in this region for 40 years, if someone had told me a couple of years ago, or 5 years ago, or 10 years ago, that the Caloosahatchee was playing such a significant role on red tide on the West Coast, I probably would have been skeptical myself. It was just by actually going and looking at all the data that I became a believer. I had no idea really how much nitrogen is coming out of that system to develop. Like I said, it's almost, you saw it's 61, it's almost the total water coming out of the total nitrogen is almost as much as the rest of the watersheds in the region combined. So better management of Lake Okeechobee Everglades restoration that will reduce harmful algae discharges and algae blooms in Southwest Florida, having more protective policy. It has, I think significant policy implications in rethinking that. And it extends all the way up into the lower end of Tampa Bay in terms of how, affect red tide. One of the advantages.
Sorry.
Oh, now we get a glitch again. Okay, there it is.
Yeah, and as mentioned, there's all other projects to reduce nutrient loads that are important investments to make. Because this is not just about the duration of tide, there's a lot of other water quality issues and symptoms that we're seeing. So reducing fertilizer use and all the wastewater upgrades, conversion from septic to sewer, or upgrading sewers we're talking about, and stormwater system upgrades are all important.
But a question, on those four, could you assign percentages as to how much each one of them is problematic? Like if you were totaling 100%.
Well, this would just be my opinion, but I would say wastewater upgrades would be number one. Fertilizer reduction will be number two. Those are to me the primary source. But septics, when you talk about upgrading wastewater plants to AWT, what you guys are talking about with the denitrification system in septic tanks, where they can be upgraded now and have to be in springs areas away in the BMAP, you're basically taking wastewater septic tanks to advanced wastewater treatment to do that. So upgrading wastewater treatment plants is pretty much simply for nitrogen, you're adding denitrification, you're removing nitrate. That's the same issue you have with septic tanks. So adding the denitrification is kind of like an advanced wastewater septic system upgrade. So anyway, upgrading wastewater systems to remove nitrate, I would say is high in fertilizer. I've been a stormwater engineer, my entire career. Stormwater upgrades are important, but honestly, if you could get the sources, then stormwater is just low nitrogen water at that point. So
Right,
anyway, that's my opinion.
thank you.
Is there one more slide?
Yeah.
Yeah.
Okay.
So basically preventing more nutrient pollution from entering waters is of course the approach of the National Estuary the program, but in particular the Caloosahatchee and Lake Okeechobee it is something that we wanted to make sure was on the radar. We're going to be talking with the Council of Counties later this year that manage and oversee kind of the management of this whole system. This is not, the east coast of Florida, I think has been a lot more successful in trying to reduce discharges that cause the blue-green algae over there from the St. Lucie discharge. But this is not a competition. We're in the same, really in the same boat as them, and we just need to have these discharges managed much better and reduced from the Caloosahatchee or from the Lake Okeechobee, in my opinion. It's going to protect the Gulf of Mexico from these severe red tide events and how long they last. So with that, I'll turn it over to Jennifer. Any questions that you might have?
I got a couple, sounds real simple to me, developing the outdoor, but there's a lot of people looking into that. If they have related restoration activities involved now with the completion of all those kind of projects, in the buildings. Well, decade, getting that water right, but my question about your particular study, this is strictly empirical, just data driven, there's no, like you said, there's no modeling involved. But I'm surprised you said that the overwhelming impact from the Boots and Hatches. So what you're saying, if we just cut off flows from east and Myakka, that the Boots and Hatches is actually exacerbating red tide all the way up to the coast.
Yes, okay, so what it's saying is that the loads coming out of Waxahachie, inclusive of the Lake Oakland discharges, are correlating with how long the red tide event lasts.
Regardless of where the red tide is occurring.
It's occurring in that geographical area.
Because I mean, when I see like when I see the high releases from Waxahachie, and typically we'll see the canic water, you get an idea where that is coming from. And I don't see it migrating that far north, but perhaps it's creating a balloon and there's other factors that are moving the red tide or, wind driven and everything else.
That's right.
There's a lot of dynamics.
There's a lot of that, yeah. So this,
Just trying to get my hands.
we're not,
Right
this is
there.
not trying to predict those dynamics.
Yeah.
Or where it is, how severe it is. It's just saying within this geographical area, and it does move. It can't move, it can't even go north, like it showed at the beginning, but all it's saying is the amount of nitrogen, the bank of food that's put in right when the red tide event starts will affect how long it's gonna last from the Waxahachie. So that's all it said.
Thanks, it's powerful and very interesting. So you didn't control for any other variables, like weather, period of availability of light or anything?
No.
This is just a straight loading.
Yes.
Because from a policymaker standpoint, it would be helpful to know some of those things because we have to discharge and actually we need to discharge in the spring. The system needs the water. So it would be nice, it would be good to know sort of what other, what's the best time to discharge and if I have.
Yeah, so this is a really good question. So what we know is from all those red tide events, we know pretty much a window of when red tide starts. And I would say of those 12 events, 8 of them or so started in September, October, okay? You may have a few then that's beyond that. But if you look at the window of time when red tide normally starts, the temperature has to be below typically 86 degrees in the water. And you go 30 days before and 30 days after that window. That would be the window that theoretically, if you could reduce or cease discharges, you could affect the duration of all the events. Doing that, I believe that you could discharge from, I think it's January through April or May, which is probably the time that you really need to have it, because that doesn't really affect the red tide. The other thing is the dynamics of those flows. I mean, it's so much more water in the wet season than dry. And I don't know if people really understand how significant that change is. So those low flows are not really the issue, both in their magnitude and when they need to occur. It's the high flows during the.
So it really becomes, to me, you've got to take the nitrogen out because there's nothing I can do about discharges right now because we're not discharging, it's basin flows. It's raining, and it's like a river, and there's nothing I can do about that. So we got to, nitrogen out of what's going in the river.
Yeah, well, especially for the Waxahachie watershed, that's all you can do. But for the Lake Okeechobee discharges, that's almost artificial. The volume, the magnitude of it, it never used to happen long, unless there was a lot of water you could spill out. The problem is that you can only get nitrogen down so much, and you still have all that volume. So whatever concentration, maybe you can get it down to let's say 1 milligram per liter. You still have that 1 milligram per liter times thousands and thousands of acre feet or tons of water that you still have to deal with. So it becomes, it's really for Lake Okeechobee, I think it's more a volumetric issue. For reducing the load, but for loose hatching, it's concentration reduction and volume, oh, either one. But
Oh, thanks.
Is reverse osmosis an advanced, water treatment method?
No.
No.
no, it's more of a desal method to get minerals and chloride out of the water. It's used, typically in groundwater. It's high in mineralized content and brackish to make it fresher.
Okay, so it doesn't help with the rid. Thank you.
Okay, thank you.